Good morning everyone. Welcome to today's maths class. Today we are going to start a new chapter, that is understanding quadrilaterals. Okay? Actually I have given the introduction of this chapter recently in an online class. We have learnt many definitions like what is a polygon, what are the different types of polygons, regular polygons, irregular polygons, convex polygons, concave polygons, and the different names of the polygons based on the number of sides of a polygon and the number of diagonals present in a given polygon and its formula. All these points we discussed in the online class. Okay, so by keeping all those points in the mind, let us go with the problems from the exercise 3.1. Okay, now look at the first problem. Okay, given here some figures. See, there are 8 figures I have drawn on the board. Okay, now classify each of them on the basis of the following. Here see the classifications A, B, C, D, E. We have to classify these figures into this one. Now the simple curve. What is meant by a simple curve? If you start drawing some figure, I have started at this point. If you come to this starting point without touching the line at any other point, if you come to the starting point, then it is called a simple closed figure. Okay? Otherwise, if you start at this point and before you come to the original point, if you intersect the line at any point, then it is not a simple closed figure. Why? Because it intersects the given line itself at some different points. Okay? So now look at the given figures. We have to classify which of the following figures, given figures, are simple curves. Okay? The first one is it a simple curve? Yes. If you start drawing this shape from a point like this without touching or intersecting any line, you can come to the starting point. The starting point and ending point, we can come to the starting point without intersecting the given curve or line itself. Such figures are called simple curves. So first one is a simple curve. Okay, one. And look at this. The second one is also a simple curve. Why? Because we can draw this figure without intersecting the given curve or line at any point. We can come to the starting point. So this is also a simple figure or simple curve. Now look at the third one. It is a combination of two circles. So they both are closed figures and simple curves only, but it is a combination, so we can't tell it as a simple curve. We can leave it. Now look at this one. Already we have discussed here. We have drawn here. This is not a simple figure. Why? Because before you come to the starting point, we are meeting the line at many points. Here 5 points I think. So it is not a simple curve. Okay. Now look at this. This is simple curve only. We can start at a point and without touching or intersecting the curve, we can come to the starting point. So this is also a simple curve. Now look at this one. So this is also a simple curve. Simply we can draw like this without intersecting the curve at any point. This is also a simple curve. So 6th one and 7th one are also simple curves. Now look at the B. What is that B? Look at this. Simple closed curves. So 1, 2, 5, 6 and 7 are simple curves. Among them, no figure is opened. So all those figures are closed only. So what is meant by a closed figure? If you start drawing a figure, so if you come to the starting point again, if the starting point and ending point both they come together, without intersecting at any point, we can call it as a simple closed curve. So the first one, second one, fifth one, sixth one and seventh one are all simple closed figures. The same answer we can write for this one also. Okay. Now look at the, see, polygon. What is meant by a polygon? A polygon is a simple closed figure with finite number of sides. So a polygon starts with 3 sides. So already we have discussed in the introduction class, if there are 3 sides, we can call the polygon as a triangle, and if there are 4 sides, we can call it as a quadrilateral, pentagon, hexagon and so on. So here, so look at this figure. Here this is a closed figure, simple closed figure, and it has 5 sides, so we can call it as a polygon. So first one is a polygon, and look at the second one. In the second one there are 4 sides. What is the name of a figure which has 4 sides? Yes, it is a quadrilateral. So it is an example for a quadrilateral. So it is also a polygon. And this is not a polygon. Why? Because a polygon must have the sides as straight lines, but it has curved lines. Okay, so it is not a polygon. So first of all, it is not a polygon. Why? Because it is not a simple closed figure. So the first condition is a figure must be a simple closed figure to be a polygon. As it is not a simple closed figure, it is not necessary to check whether it is a polygon or not. And it is also not a polygon. Why? Because it has curved sides, curved outlines. So a polygon must have the sides as the straight lines. So it is not a polygon. And this is also not a polygon. Why? Because here we have curves. Okay. And this is a figure with 2 sides and a curve also. I told you already, a polygon never have any outline as a curve. So it is not a polygon. And this one also having some curved outlines. So it is also not a polygon. So among these 8 figures, the first and second only are polygons. Okay. Now look at the next one, D. Convex polygon. We can check whether the given polygon is either convex polygon or concave polygon in 2 different ways. So let us go with the first one first. Okay. So whenever you have a polygon, you try to draw a diagonal. So it must lies entirely in the interior of the polygon. So whenever you draw a diagonal for a polygon, it must entirely lies in the interior of the polygon. Then we can call it as a convex polygon. For example, look at this. If I have taken a square like this, if you draw its diagonal, does it lie inside the quadrilateral square? Yes, inside. Now this one, this is also inside. Now if you take a polygon like this, if you try to draw this, join this point and this point, so does it lie inside, entirely lies inside the polygon? No. Some part of the diagonal has come outside also, this part. So it is not a convex polygon. Now in the same way, if you try to draw a diagonal, this diagonal is okay, it lies inside only. And this diagonal is also okay, it lies inside only. If you try to join these non-adjacent vertices like this lies exterior of the polygon. So we can say it is not a convex polygon. Okay? So like that we have to check. Now look at the second one. If you try to draw the diagonals, the first diagonal entirely lies inside only. Now the second diagonal also lies inside the polygon. So this polygon is a convex polygon. First one is a convex polygon, whereas, sorry, second one is a convex polygon, whereas the first one is not a convex polygon. Why? Because when I try to join these two vertices, the lines so formed is exterior of the polygon. So this is not convex polygon. This is a concave polygon. Okay. So we have completed the first problem. Let us continue with the second problem. What is that? How many diagonals does each of the following have? Okay. Let us continue. Now the second problem. How many diagonals does each of the following have? The first one, a convex quadrilateral. See, this is a convex quadrilateral ABCD. So if you try to draw its diagonals by joining the opposite vertices, we can get one diagonal like this and another diagonal like this. So is there any chance to get one more diagonal? No, there are two diagonals. We can find out the number of diagonals of a polygon by using one formula also. So we have discussed in the introduction class. What is the number of diagonals present in a polygon? So let us write here. Number of diagonals of a polygon with n sides is equal to n into n minus 3 by 2. Okay. So now by using this formula also we can find the number of diagonals of a quadrilateral. Quadrilateral means n value how much? 4. There are 4 sides in a quadrilateral, so n value 4. Therefore, number of diagonals is equal to n into n value 4. 4 into 4 minus 3 by 2. 4 into 1 by 2. That is equal to 4 by 2, 2. 2 correct only? So we can check by using the formula also. This is formula method. This we can check it by drawing, actual drawing also. Now let us try to draw the diagonals, number of diagonals for this. Actually, so by drawing we can find how many diagonals we get. That we will check with the formula also. Now see, here diagonal 1, diagonal 2, diagonal 3 from B, diagonal 4, diagonal 5 and diagonal 6 from C, from diagonal 7, diagonal 8 from D, diagonal 9. We got 9 diagonals. Whether it is correct or not we have to check. It is a regular hexagon. Okay, first let us check the number of diagonals correct or not. N value here, it is a hexagon, so number of sides is equal to 6. Therefore, number of diagonals is equal to n into n minus 3. 6 into 6 minus 3 by 2. 6 into 3 by 2. That is equal to 18 by 2. 18 by 2 means how many? 9. So we get 9 diagonals only. Okay. So it is a regular hexagon. Do you know the difference between a normal hexagon and regular hexagon? So let us recall once. So hexagon means 6 sides. See how many sides it has? 1, 2, 3, 4, 5, 6. But all the sides are not in the same length. But here you see all the sides are equal in length. So a polygon with all the sides are equal in length, then we call it as a regular polygon. So regular hexagon means a hexagon with all the 6 sides are equal in length. Okay. Now, how many diagonals we can draw for this? So is it possible to draw anything? If you join P and Q, already joined, P and R already joined, R and Q are, there is no chance to draw any diagonals for this. How would you draw? So the number of diagonals present in a triangle is 0. Here So here we will write the answer just beside it. Number of diagonals. Here how many diagonals for the quadrilateral 2? Here number of diagonals is equal to 9. We have checked also. So here number of diagonals is equal to 0. If you want, you can check like this. In the place of n, if you write 3, 3 into 3 minus 3 by 2. 3 into 3 minus 3, 0 by 2. 3 into 0, 0 by 2 is 0. See, formula also we have verified. So like that, if you know the number of sides of a given polygon, we can find the number of diagonals present in it by using this formula, and that we can check by actual drawing also. Okay, thank you. Now look at the third problem. What is the sum of the measures of the angles of a convex quadrilateral? Convex quadrilateral. Do you know what is a convex quadrilateral? If each interior angle of a quadrilateral is below 180 degrees, we can call it as a convex quadrilateral. Here I have drawn one convex quadrilateral. Okay, and see, will this property hold if the quadrilateral is not convex? Not convex means obviously it is concave. Will the same property holds for this also? We have to check. This is not convex. This is a concave polygon, concave quadrilateral. This is a convex quadrilateral. Okay, this is concave quadrilateral. Okay, now look at this. How can you find the sum of all the angles, 4 angles of this quadrilateral? Now let us see. If you draw a diagonal, that diagonal divides the entire quadrilateral into 2 parts. See, look at this. I have drawn the diagonal AC. This diagonal AC, see, look at this. AC divides the area of this quadrilateral into 2 parts. What is the each part? ABC is a triangle and ACD is another triangle. So a quadrilateral has been divided into 2 triangles by one diagonal. Okay. Now, what is the sum of the 3 angles in a triangle? Already we have learned in earlier class that sum of the 3 angles of a triangle is 180 degrees. Okay. So means 2 right angles. The sum of the 3 angles of a triangle is 180 degrees. That is called angle sum property. Now, see, here in the triangle ABC, this is one angle. There are 3 angles. So, 1, 2, 3. In the other triangle, also there are 3 angles. We can call them as 4, 5, 6. Okay. Now look at this. What is angle 1 plus angle 2 plus angle 3? Angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Okay. Angle 4 plus angle 5 plus angle 6. Angle 4 plus angle 5 plus angle 6 is equal to 180 degrees. If we add all the numbers, angle 1 plus angle 2 plus angle 3, angle 4 plus angle 5 plus angle 6 is equal to how much? 180 plus 180. So 360 degrees. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. So the sum of that means angle 1 plus angle 6 means angle A, angle B, angle C, all together 360 degrees. So sum of the angles is 360 degrees in a quadrilateral. So it is very simple. A quadrilateral can be divided into 2 triangles by a diagonal. In this triangle there is 180 degrees, and in the other triangle also sum of the 3 angles is 180 degrees. So this 180 degrees and this 180 degrees, if you add, you will get the total angles in the quadrilateral is 360 degrees. It is very simple. In the same way, does this property. Okay. Now, will this property hold for this second? What is this type of quadrilateral? It is not a convex. We call it as a concave quadrilateral. Okay. Let us check. So if you join these 2 points, do we get 2 triangles? Yes, again, the sum of the 3 angles of this triangle is 180. The sum of the 3 angles of this triangle is 180. So 180 plus 180, obviously it is 360 degrees. So answer is yes. For the second question, okay, answer is yes. So sum of the angles in a convex quadrilateral is 360 degrees. The same answer you will get even it is not a convex quadrilateral also. Okay. Now we have a formula to find the sum of the angles in a polygon. Okay. See, that is n minus 2 into 180 degrees. Okay. So by using this we can do the problems problems in the fourth Roman. N minus 2 into 180 degrees. This is the formula to find, see, sum of the angles in a polygon with n sides is equal to n minus 2 into 180 degrees. If the polygon is pentagon, in the place of n we have to take 5. Hexagon, n value 6. If it is decagon, 10. Like that, if you put the number, you will get the answer. For example, look at this. What is this figure? This is a quadrilateral. How many sides does it contain? 4. N minus 2 into 180 degrees. So let us take 4. 4 minus 2 into 180 degrees. So 4 means n minus 2. 4 minus 2 means 2. 2 into 180 degrees. 360 degrees. Okay. So by using this formula, please copy this formula. By using this formula, you have to do the fourth Roman as homework. Okay. This Roman has one table. So he has solved some problems in the table and he has given 4 problems below that. And also fifth Roman you need to do as homework. That is very simple. So homework is exercise 3.1, 4th and 5th Romans. Okay, that is the homework. Okay, let us continue the remaining problems in the next class. Thank you. Have a nice day.